Hello everyone, welcome to the video solution of Jan 24 Unit 3 IAL Physics. I have a small gift for you. What I've done is compiled all of the important concepts of literally all the recent papers into a PDF that I believe you'll find immensely useful as part of your preparation for your exams. I have also included my communication with Pearson regarding some of the questions that students find extremely confusing and what is the proper way of answering those and approaching those concepts. You'll find all of these in the PDF. The link is given in the description below. Question 1 says, a student had a stack of 500 sheets of paper. He measured the dimensions as shown. The student used a balance to determine the mass of the stack of papers. The reading is shown below. State the resolution of the balance. So this is how I teach my students about how to determine the resolution. Just do this 0.001. So this is the resolution of the balance. So of course you have to give the unit as well. So the resolution is 0.001 kg. The next part of the question says, determine the percentage uncertainty in the mass of the stack of paper. So I hope by this time you already know that there are two ways of finding out the percentage uncertainty for that matter. One is using the resolution of a single measurement, and the other one would be a set of readings. For this specific question, you do not have a set of readings. All you have is just one single reading. And when it comes to one single reading, the uncertainty is given by resolution divided by 2. So first find out the uncertainty. Uncertainty would be resolution 0.001 divided by 2. That makes it 0.0005 kg, right? So this is my uncertainty. And as always, percentage uncertainty is uncertainty 0.0005 divided by measured value 2.07 times 100. And the value is 0.024. 0.024. The question says percentage uncertainty, and once you multiply it with 100, the value is 0.024%. And as always, give your percentage uncertainty in two significant figures. So that's why I gave 0.024, which is consistent with two significant figures. Part B of the question says, the student used vernier calipers to measure the thickness Y of the stack of paper. Explain one technique he should use to determine an accurate value for Y. So guys, this question is somewhat borrowed from A2. This concept has been introduced since 24, if I'm not wrong, but this has been a very widespread concept in A2 physics. Explain one technique. So it's always a 2-mark question, and you have to choose a pair of points. So let me show you. This is the format. Either these two pairs or these two pairs. What you cannot do is pick 1 point from here and 1 point from here. So the points have to be in pairs. So this is your answer. Check and correct for zero error. And why would you do that? To eliminate systematic error. Or this pair of points, or repeat the measurements at different positions and calculate a mean to minimize the effects of random error. Like I said, you have to write this in points. Either you talk about systematic error or you talk about random error. Either one works. What you cannot do is pick points from the pair of values. I mean, pick points from the pairs and mix them up. You either have to talk completely about systematic error or completely about random error. You cannot be mixing up points from these two concepts. The next part of the question says, the student used the measurements from the stack of paper to determine the density of the paper. Determine the density of the paper in gram per cm cube. I want you all to look at the unit very carefully. Gram per cm cube. And what are these x, y, and z values? If you go up, you can see x, y, and z are basically the dimensions of the stack. So if you multiply x, y, and z, what you get is the volume. But if you look at the values, all the values are given in millimeter, but the question specifically says to give your answer in gram per cm cube. So you have to convert all of these values into centimeter. And the other value you have to convert is the value of the mass, right? That was given in kg. You have to convert that into gram. So I always suggest my students to follow a modular approach. So let's first find out the volume. X. How do you convert millimeter to centimeter? Divide by 10. So this would be 21 times this would be 4.27 times this would be 29.7. And the value would be 2663. I'm looking at my calculator right now, and the value I got is 2663. You might be wondering, why do I have to give my value in, let's say, 4SF? This is cm cube, right? That's because if you look at these values, all of these are in 3SF, right? And this tells you that most of the values are in 3SF. So you have to give your answer in 3SF, but this is not your answer. This is an interim calculation, an intermediate calculation. So interim calculations will always have to be 1SF higher. So since this is not my final answer, there is no way I can round it off to 3SF. Interim calculations has to be in 4SF for my final value to be correct to 3SF. Now you recall the equation for density. Density equals mass by volume. Of course, you have to convert the mass to gram. So the value was 2.070 times 1000 gets you 2070 gram divided by it's 2663 cm cube. And the value that you get is 0.777 has to be correct to 3SF. Actually, um, I communicated with Pearson regarding this specific question that the mass value is given in 4SF, but the dimensions are given in 3SF. Why exactly did I choose 3SF over 4SF, right? And I got a very detailed response, which I've included in the PDF. That's why I said it will be extremely useful for you. Let's move on to the next question. Explain why making measurements on the whole stack of paper is better than making measurements on a single sheet of paper. This is a very common concept, one of the most common concepts in Unit 3 physics. That is, the moment you increase your measured value, right? So let's recall the equation for percentage uncertainty, right? In any measurement, you always want to minimize your percentage uncertainty. So the equation is percentage uncertainty equals uncertainty divided by measured value. So when you are taking measurements of a stack of papers instead of a single sheet of paper, right? So the measured value is greater. Uncertainty remains the same and the percentage uncertainty decreases. Literally, this is your answer. This is a 2-mark question. This can also be a 3-mark question. And for this specific paper, what they have not marked here is the uncertainty remains the same. But for a 3-mark question, you have to include this point as well. The uncertainty remains the same. The measured value increases, so the percentage uncertainty decreases. Memorize this by heart because this is one of the most common concepts of Unit 3 physics.